All right, let's talk about AWS SQS, the simple queue service. It's one of those services that's absolutely everywhere in the cloud, but sometimes it feels a little mysterious. Well, by the end of this, you're going to see it for what it is, the ultimate buffer that can literally save your applications from total chaos.
So, what happens when your success is actually your failure? It sounds weird, right? But in the world of software, this is a very, very real problem. You build something awesome, people start loving it, and then a tidal wave of traffic comes rushing in, and bam, the very success you were dreaming of is what takes your entire system down.
I want you to picture this, because it's a classic. You've launched a massive flash sale. The traffic is insane, way better than you expected. But your backend, the part that actually has to process all those orders, it just can't keep up. It's drowning. The database freezes, servers are screaming for memory, and just like that, nobody can buy anything. Your biggest win just turned into your biggest outage.
And that, right there, is what we call the million-order crash. It's that moment when the demand you worked so hard to create just completely swamps the system you built. So the question is, how do you handle a tidal wave without getting totally washed away?
Well, this brings us to the hero of our story, SQS. Seriously, it's not just another piece of tech. It's the elegant, simple solution to this exact kind of chaos. It's the thing that stands between that flood of requests and your backend, creating a little bit of order and a whole lot of stability.
So what is it really? Okay, the official term is a fully managed message queuing service. But let's just cut through the jargon. The best way to think about it, and this is the analogy we're going to stick with, is as a buffer. That's it. It's a waiting line. It grabs all those incoming orders or messages and just holds on to them safely until your system is actually ready to deal with them, one by one, at its own pace.
So let's look at how it works under the hood. The most important thing to get is that SQS is a pull-based service. This is key. It means your servers, the consumers, they're the ones who ask the queue for work, but only when they're free. Messages aren't being shoved at them. They pull work when they have capacity. And because this is AWS we're talking about, it's all super reliable and distributed right out of the box.
Okay, so we get it. SQS is a waiting line. But what's actually happening inside that line? Let's follow the journey of just one single message, from the moment it's created to the moment its job is totally done.
The whole life cycle is just this simple four-step dance. First, a producer sends a message to the queue. Step 2, a consumer pulls it down, and this is crucial. It hides the message so no one else can see it. Third, the consumer does the actual work. And finally, once the job is done, the consumer deletes the message. Cycle complete.
Now that hiding step, that's the secret sauce. It's controlled by something called the visibility timeout, and it's basically a genius safety mechanism. Think about it. What if your server crashes right in the middle of processing an order? You don't want that order to be lost forever, right? Well, after this timeout, say 30 seconds, if the message hasn't been deleted, it just reappears in the queue, totally visible again, ready for a healthy server to pick it up and try again. No data's ever lost.
And speaking of safety nets, get this. SQS can hold on to a message for up to 14 days. Let that sink in for a second. Your entire backend could go down for a week for some major maintenance. And when it comes back online, all those orders, all those messages are still there, safe and sound, just waiting to be processed.
Okay, so we know how it works. But here's the thing. Not all waiting lines are created equal. In SQS, you got to make a big choice between two different kinds of queues. And believe me, it's a critical decision for your architecture. So your choice is between standard queues and FIFO queues. Think of it this way. Standard queues are built for one thing, maximum speed, blazing fast throughput, but they only offer best effort ordering, which is a fancy way of saying messages might show up in a different sequence than they were sent. FIFO queues, on the other hand, are all about order. They guarantee first in, first out processing. So the big question you always have to ask is, do I need raw speed or do I need perfect, predictable sequence? All right, now let's level up. Beyond just picking the queue type, there are a couple of key settings that can take your setup from basic to a professional, cost-optimized machine. These are the little details that really matter in the real world. First up is polling, which is just how your servers ask for messages. Now with short polling, they ask and SQS replies immediately, even if the queue is totally empty. This can lead to millions of empty responses, and guess what? You pay for every single one. The pro move is long polling. With this, your server asks and SQS actually waits for up to 20 seconds for a message to show up before it replies.
This one change can slash the number of empty responses and is, without a doubt, the #1 key to saving money with SQS.
Next is another absolute lifesaver, the dead letter queue, or DLQ. So what happens if a message is just cursed? Maybe it's malformed and it crashes your app every single time it gets processed. Without a DLQ, it would just keep coming back to the queue, crashing your app over and over and over again. A DLQ is like a special quarantine zone. After a few failed tries, these poison messages get sent there so you can figure out what's wrong without taking down your entire system. All right, enough theory. Let's put all this together and use what we've learned to solve some classic real-world problems. Let's think like a solutions architect for a few minutes.
So here's scenario number 1, the scaling problem. Your app lets users upload images, but the processing, resizing them, running some analysis, it takes a long time, like 5 minutes. Your users are hitting upload and then just staring at a spinning wheel until their browser gives up and times out. It's a horrible user experience. What do?
The SQS solution here is just textbook perfect. You decouple the system. The web server's only job now is to take the image, drop a message into an SQS queue, and immediately tell the user, "Got it, your upload was successful." Then, a whole separate fleet of worker servers can pull from that queue and do all the heavy lifting in the background. The user gets an instant response, and they never have to wait.
Okay, scenario 2. This one hits you right in the wallet. You open up your AWS bill and, whoa, your SQS costs are way higher than you expected. You dig in and you realize your app is making millions of calls to the queue, but most of the time the queue is empty. How do you fix that?
And you already know the answer to this one, don't you? It's simple and it's incredibly effective. You enable long polling. By changing just one parameter, you tell your system to stop frantically checking and start patiently waiting. This one little tweak can easily cut your API calls by 90% or more, and your costs just plummet. And for our final scenario, the poison message. A bug in your code, or maybe some bad data, causes one specific type of message to crash your application every single time. It gets picked up, it crashes the app, the visibility timeout expires, it reappears in the queue, and the whole horrible loop starts all over again. How do you protect your system from that?
The safeguard is, of course, the dead letter queue. You just configure your main queue and tell it, hey, if any message gets picked up more than, say, 3 times, something's definitely wrong. After that third failure, SQS automatically yanks that poison message out of the mainline and puts it safely in the DLQ. The loop is broken, and all the healthy messages can keep on processing just fine.
So, to wrap it all up, this quote really nails it. While other services like SNS might be about broadcasting information out to many places, SQS is the buffer. It's that crucial waiting line that absorbs shocks, smooths out those crazy traffic spikes, and lets us decouple our systems. It is absolutely fundamental to building modern, scalable, and resilient apps in the cloud.
So that leaves us with one final thought. We've seen how SQS can be this incredibly powerful buffer, solving huge bottlenecks in scaling, cost, and reliability. The real question is, now that you have this powerful tool in your toolkit, what's the first bottleneck you're going to solve? Thanks for tuning in.